think we're live. Hey, Drew.
Ooh. Hey, how's it going?
Good, good. How you been?
Pretty good.
Yeah, that's good.
Mhm.
So, what do we have for today?
Well, today we're going to continue from where we left off last time. We talked a little bit about HTTP. We talked about different types of requests or methods, and we showed some examples, an example that might work, but it was partial. So we wanted to show fully working examples, and I think we wanted to do a get, a post, a custom method that we called Scream, and then a default method, and we wanted to build out a web API that would be able to handle that, and then also hopefully a way to interact with it. There's a few things there that we could maybe unpack as well, but that's basically what we were going to start with, and we're going to look at doing that using Go.
Okay, excellent, excellent. Okay, so let's jump into it a bit. I'm just gonna share my screen.
Okay.
Oops, that is not the way I want to share my screen. There we go. There we go. Okay, so we're sharing the screen. Okay, so like we've both been doing this for a while, but just for anyone who hasn't, typically when someone has wants to start something off, they might start off looking at the documentation. So for us, I'm going to go to Golang and search for HTTP. Let me make this bigger. So I search for Golang HTTP. I'm going to go to the docs. Now I've done enough Go that I have a lot of this memorized, but I think it'd be useful for us to kind of like talk this out and think this through and all that.
Absolutely.
So,
I think one of the things that is often overlooked is that becoming familiar with how to actually read documentation can be a challenge in and of itself. There's the RTFM, what some people say, read the fine manual. I guess that's the polite version of it. But the funny thing there is that I think for a lot of people when they're first starting out, especially if they have issues with even knowing some of the simpler commands like :Q to quit out of the documentation or things like that. Learning to read the actual words or like how to parse the information and find what's useful can be very difficult. And so, or at least not as intuitive until you become at least familiar with like one set of documentation. And I think it translates really well to other documentation. But when you're initially learning the concepts and learning the things, it doesn't always make sense, and that's okay. So you got to get a little bit used to it. And I think that like what we're doing right now, showing the docs and then looking at it, it can be a good, get your feet wet and at least just know that this exists.
Yeah, exactly. Okay, so when I start off, I would want to do the project somewhere. I tend to work from the console. Certainly, like, people should work where they're comfortable. Like a lot of people use IDEs. Like I think you use VS Code.
Yeah.
I just got used to using the command line like a long time ago. So I'm going to continue to do that. So there was already a main here, but I'm going to remove that. So I'm just going to show there's nothing in here. And I don't know, like a lot of people might be unfamiliar with how to use a command line. It's something like once you know the commands, it gets very straightforward, but it can be a little daunting because you don't know what to type. So
Yeah, I think we've talked about this a little bit, but I think what we might want to do is for our Twitch, for our live stream, we can just go over the concepts, and we don't necessarily have to explain too in depth. We can kind of assume that people listening are maybe an intermediate developer and they understand a lot of these things, but it's just sort of solidifying the concepts. And then if somebody's more of at like a beginner level, then it might be interesting to see this and see like that, oh, this kind of stuff exists. But we'll follow up with more of a tutorial focused video as well, with like a link to a repo and stuff like that, and a README, and then that can be attached in the playlist.
Sounds good. So I created a file main.go, and you started off package main. This is kind of like where the computer, or it's the main thing that runs, right?
Yeah.
And with
So
Go,
so
you
so I also hear, entry point. It's the entry point into your program
yeah,
often. With Go, and I guess that's some other programming languages, you have the idea that there's a main function, and so that's your main entry point into your program, the main thing that runs. But also there's init, and that can be used. Actually, that gets run just before main, doesn't it, to set things up?
yeah. So conceptually, the way a lot of people think of it is that your program starts at main, but you're absolutely correct. There's a lot of stuff that happens before you go to main, right? And if you do little, some stuff that are maybe a little more advanced, you might need to initialize some stuff, right? Like maybe
Mm.
you got to get a database, initialized and set up or configured. Like where's the database? Where am I going to connect
Yeah.
to? And maybe you don't do the main. Maybe you've kind of divided that up into its own package. And the way you get something to run automatically with the package is doing an init, so that
Mhm.
everything's set up and ready to go with main. Because maybe main doesn't want to have to worry about the details of whatever your package does, right? It just wants to use
Sure.
it. And it creates a nice developer user experience. So often when I do these programs, I'll just like start with a hello world. I just want to make sure things work. So,
Yeah.
I'll save that. I'll go back to the command line, and maybe I'll do a quick one. I'll just do go run main.
So I find that too. Like typically, whenever I'm doing something, I don't like to get too far ahead of myself before I check to make sure that things are actually working.
Yeah,
And
yeah,
and by too far ahead, I mean it kind of depends, right? Like how much I can hold in my mind, and um, how far I've gone through the thoughts and through what I'm building. But typically, I'll stop pretty often just to run something and see, like, oh, okay, it's working as expected.
yeah. Same thing. And like I actually made an error because I haven't done this in a while. I needed to import the format package. Some people call this font. I call it format.
Yeah, me too.
Um,
So this is actually like you're using Nano, which is obviously fine. Like everybody has their own preferences. One of the reasons why I liked VS Code and initially decided to use it, I'd heard a bunch of people talking about it. It was even on the Go Time podcast, and I think, oh, that's right. I got a new computer because I'd started a new job,
yeah,
and rather than spend half a day or something configuring Vim and all of my packages and setting it up to be uh, comfortable to work in, I thought, you know what, I'm just going to try VS Code, and I'm going to download this one extension for
yeah,
Go.
yeah.
It's like the Microsoft maintained one, and it just includes kind of everything that you might need. So in the case that you just had that error for not importing the package, you wouldn't have had it because it would have auto imported.
Yeah, that's correct.
Yeah.
I think for me, part of it is that I think I've been using the command line for a long time,
Sure.
since the early 1990s, so I'm very used to it.
Yep.
There are things that occur in IDEs I actually like. Like I like that you can click on a function name and get magically sent to the where it's defined, right?
Yeah.
But I don't like using the mouse when I program. I like doing everything from the
Yeah.
keyboard, which is why I've kind of like stuck to this. If
Makes sense.
if I had a keyboard oriented interface, maybe for an IDE, and like I didn't lose all the stuff I had working from the command line, because I got a bunch of commands I can like mash together to do stuff.
Yeah.
I might try it, and I have tried it. I typically come back, but
Yeah,
um,
I think it's like what I guess my first few years of development, I thought that like using something like Vim or um, something through the command line, it just felt more like hardcore, I suppose you
yeah,
might say. So I thought it was cooler, but yeah, I guess I don't have like very strong preferences, and um, it could go either way. But right now,
yeah,
I'm actually pretty used to VS Code.
yeah. It's not say my choice is better or worse or anything. It's
Yeah,
just what I'm used to. I mean, that's really it. It's like
makes sense.
I learned this and I just kind of kept with it.
Yeah.
Okay, so that works fantastic. Now what do we want to do? Okay, so if you think back to last time,
Mhm.
we were playing around, we were learning HTTP, and we acted like a web browser, and we used kind of telnet to help us pretend to be a web browser, and we connected to the server, and we wrote a HTTP request by hand, which is pretty cool.
Mhm.
And also there was another end to that. There was being the web server, right? And we talked about the methods and all that other stuff. And what we want to do is we want to be that web server.
Mhm.
um, I think what I'll do is I'm just going to do the telnet thing just one time. just to kind of like refresh people's memory, just in case anyone's forgotten. So I'm just gonna.
It's a good idea.
Yeah. So let me just get rid
So
of
maybe we
that.
can go. We can maybe go over like what is an HTTP request again.
Yeah. So when you're using your web browser communicates with a computer somewhere on the internet, and it says like, for example, like if you had this URL. Oops, sorry. I think this is the URL we were using last time. Oops, if I could spell. If you go to that, your web browser, you put that in your web browser, you click a link that contains that, and it takes you there magically, right? And well, what does that mean? Well, this right here, right? That's a domain name, right? And this will get translated into some number, like maybe something like, I'm not saying it's this. So you can think of this like this number here. You can think of this kind of like being a phone number for the people who still remember phone numbers. Like, Drew, you might have the phone number 604-555-5555. But in my phone,
That's
I don't
not
have
my number, by the way.
Yeah, of course. But
don't call me on that number.
In my phone, I don't call that. I don't dial that out, right? Yeah. What I do is I store it in my contact list, Drew, right? And that's what this is like. That's what the domain is like, right? Yeah. So there's a lookup, right? And the way the internet works is kind of like everyone uses a shared address book, right? And it's not something you really have a control over. It's something someone else has control over. But you all go look everything up in that. So like Drew, I would go look up, in this case, our domain's www.example.com, and it would give you back the phone number, or if you're on the internet, the IP address, right? And then once you've kind of done that lookup, right, like it finds where that computer is, it dials it up, then it's going to ask for something. So you ask for this URL, but once you've done this lookup and you go to that server, what you're really trying to get is this, right? You want that, right? So the way it does it, the way it communicates, is it uses a language. I'm gonna just move this up so you can see it, and I'm gonna start writing. So it would do get, right? And then it would include this, the path right there, and then it would add this to the end. This says, hey, when I'm talking to you, this is HTTP version 1.1. Right, and that's just the syntax for it. Like maybe in the future there's 1.2 or 2 or 8 or whatever, right? But we're going to do 1.1. And then for certain reasons, it also needs to tell it the name. I'm not going to go into the reasons now. If anyone's interested, I can go into why. But it's going to add this header, right? And what's a header? Well, it's this this kind of construct, right? We have a key host, right? And it has a value, www.example.com, kind of like, when you do assignment, like, like programming x equals 5, well, host equals that, right? And then we're going to add one more header, action close. And last time we talked, I said I wasn't going to explain what this means. This basically means I only want to do one request, and then I'm not going to ask anymore. The reason is that by default, the server will assume you want to do a whole bunch, because that's often the case. You download a page, you have a bunch of images, I need to download those too. So you're going to make a bunch of requests. But we want to just, kind of keep this example simple, so we'll add these 2 headers. Really, your web browser adds a whole bunch more headers. Like it might do stuff for like, sending cookies, or maybe saying, oh, I downloaded this page before, here's the version I last had, or whatever. And even like might tell you like, hey, I'm this browser, just in case you were curious. So it does this. So let's do something like that too. So we're going back to the console. I'm going to just clear this, and I'm going to do a little trick like we did last time. I'm going to connect to this server. Like I don't have to do that lookup, that translation myself. I'm going to let Telnet do it. It's going to do it for me. So it's going to do a thing where it translates www.example.com to the IP address. Just like my phone would translate Drew into your phone number. And then I'm going to put an 80 here. This represents a TCP port. We'll get into this later, but just if you're curious, the TCP port for HTTP typically is port 80. It's like just they chose that, right? And then I'll just do this once. I'll just kind of show, then I'll do it again. So if I hit enter, I get a bunch of like this stuff written. You should ignore this. This is just Telnet speaking. It just does this. This isn't part of HTTP or TCP or anything like that, right? So let me just clear that, and we'll do this again. And then this time when I hit it, right? So there's going to be those 3 lines. You're just going to ignore that because it's not part of HTTP. And then what I'm going to do is I'm going to copy and paste this. And I need to put 2 inters after it, right? And the reason is because some of these things, like if instead of get, I had post, what would happen is there'd be another line and I'd have like, a whole bunch of data I might send. Like it could be in this format. Oh, nice. Doesn't follow my pattern. It can be this format, or maybe it's like, JSON. Whatever. There's a little more you need to add to this. Like I'm leaving out a lot of stuff because I don't want to make it too complex, but that's the basic idea, right? So I need 200. So I need get, right? Okay. So I'm going to copy this. Oops. Let me copy the whole thing. I'm going to copy this and I'm going to have this ready. And now I'm going to go run this. So I hit enter and I paste it and then I hit enter again and bam, right? So what happened? Like I pretended to be a web browser. So let's go up. And, I use Telnet to connect to www.example.com. Hopefully that's legible.
Yeah.
And this is the request I made. So this is what your web browser sends. So if you're using Firefox or Chrome or Safari or, whatever, you're going to see your web browser is going to send something like this. It's probably going to have some more headers. This one has host connection. It's going to have a bunch more, but it's going to be basically send this. And then on this line and everything below it, this is where the response from the server comes. And this is what we're going to do. We're going to be the server.
So actually, if we look at this, like HTTP 1.1, and then it says 404 not found. So this code, I mean, people are probably pretty familiar with some of the codes. I'm sure 404, well, maybe not everybody, but a lot of people will have heard of this or at least seen it at some time on the internet. What are these codes? What do they mean? Can you tell us a little bit about that? Are they, is there a standardization of them?
Yeah. So with the HTTP protocol, so this is what we're talking. This is what I typed up here. There's 2 parts of it, right? There's a client and a server, right? And it's just names they gave them. The client asks for things. The server gives you things. And with the server, when it gives you something, the first line is very special, right? It kind of sets the context to everything else. So in the same way when we made a request, right, and here's the request we made, we told it what version we're speaking, right? The server will do the same, but it puts in the beginning, right? It puts in the beginning. And it says, okay, I'm speaking HTTP version 1.1. And then what happens is right after that, you're going to get a numeric code. And these numeric codes are part of HTTP. It's just like it's a common convention that everyone knows. And there's documents that even explain all this, right? So for example, if I was to go here, codes, hopefully that comes up. Let's go here. Let me make that bigger. This is some documentation made.
Actually, could you go up to the scroll up just a little bit to the there we go.
Yeah, that's a good place.
Yeah.
So the HTTP codes, like, so this is what the server returns on the first line, right? So like in our case it was 404, but it could be lots of different stuff, and we can even like make up our own, but we'll get into that later. They're divided into 5 different types, right? So like all of them are going to be like 3 digits, right? So it could be like 100, 200, 300, 400, 500, 238, 57, like it's just 3 digits, right? So the digits from 100 to 199, it calls informational, right? And we'll go into that a bit more. The ones from 200 to 299, so anything that starts with 2, right? These are successful, right? So for example, if this page was here, right, what I would get instead of a 404 might be a 200. It's like, and 200, like the English, like the human description of that code is okay. It's just literally like okay. Like you can see here, like we have 404, and there's also right after that, we haven't gone over it yet. Right after that, there's a human description of what this code means. 200 is okay. And then there's redirects. So what are redirects? if you've noticed, sometimes you might put a URL in the browser and then the browser takes you somewhere else. It changes the URL. This is where you see that kind of stuff. And there's different kinds, and they mean different things, but you see them in tenure. And by the way, I should say that, when it says something like 300 to 399, it doesn't mean every single, number in there is used. Like most of them are unused, right? For a long time, people were using, I think, 301 and 302. There's some other ones like 30, I think 307, 308, and there's some other ones, but like most of them, there's nothing assigned to it.
Which one's I'm a teapot?
Oh, I don't remember right now. I can look that up. That's a good
But
question.
yeah, that's right. So these are the ranges, and like you said, you can make your own custom ones. So,
Yeah.
but they should probably follow the convention of, if it's within the 100 range, it's an informational response. If it's within the 200 range, it's a successful response. If it's within the 300 range, it's a redirect response. Client errors and then server errors.
Yeah, and it depends.
So in this case, this is actually interesting, client error and server errors. So client error, in this case, because we're requesting a page, we're saying, I'm looking for information. So I've gone to the server or the computer, right, that's located behind example.com at that address. And I'm saying, hey, I'd like cherry.html. So this is kind of similar to, like, if I went to a building, maybe an office building, and I said, I'm looking for the Cherry Corporation. And they said, I'm sorry, there's no Cherry Corporation here. Yeah. So who's wrong? Are they wrong? No. Like, who's got the error?
Well, you've got a mistake. Yeah.
Right. You've got the error if you're looking for something that's not there.
Right. So it's like you made a mistake. You thought the office was in this building. It's not. Right. And like, you're right. Like the 400 class responses, those are, the web browser or the person using the web browser, or maybe someone gave them bad advice, you made the error. Where the 500 ones is like the server had an error, right?
Right.
And an example,
so that could be like, our elevator's broken, you can't do it, exactly. And the stairs are out of order for whatever reason, so you can't get there.
Yeah, an example like with a web server might be I couldn't connect to the database, or like something crashed, like some program was working and it just broke. Right, and that would be like something you would have a server error for. Mm-hmm. A common one, and like it's kind of like 404 is kind of famous because people have seen that a lot. Another one is 500. That's a really common one, and it just means it's
or 503.
Which one's 503? I don't remember 503? That. Oh yeah, service unavailable. I've seen 500 a lot more, but it's just like a generic error that can mean anything, right? Like I don't have a specific, I can't get any more specific, or I don't want to. So just 500, something bad happens on the server end. That's basically what it means.
And you often don't expose that to the client, right? Like what actually the issue was, where it might be logged on the server side for a server admin to look into, but it's pretty unlikely that you're going to say, oh yeah, we have your email address, but we don't have the, or well, I guess actually that might be a client error, but
or like the password for the database is wrong or something like that. Someone misconfigured.
Yeah, exactly.
Yeah, you could, like, it's the decision of the person programming it, but typically you probably wouldn't.
Right.
Okay, so you have all these codes, and like this is something people should look through, right? Like if you're programming backends, doesn't mean you have to memorize it. But like you'll probably go to this, right? Like what does this mean?
It's good to know that this exists, right? And then as you get some familiarity with it, like it might not make sense right now, and there's no point in trying to memorize it if you don't know all of these things already.
Exactly.
But once you have an idea that, like, okay, there's these ranges. So if I see an error, or if I see a message, an HTTP message that's within one of these ranges, chances are that if people have followed the protocol, then it's going to be a meaning like this. So if it's a 400 in the 400 range, then it's a client error. If it's in the 500 range, it's a server error. If it's a 100 range, it's informational. If it's a 300 range, it's some sort of redirect. If it's a 200 range, it's some sort of okay.
Yeah, and you can notice, like I was saying, like if you look at the redirects, the 300 class, you have 300, 301, 302, 303, 304, 305, 6, 7, 8, and then nothing, right? So 309 all the way up to 399, no one's using it.
And it's kind of interesting, like, 'cause if you look at like the 308, it says permanent redirect, but so does 301, does it?
Yeah.
And I think it might be like, depending on how much you care, it might be worthwhile to read up on oh, what do you call it? Search engine documentation to see how using these codes may affect your SEO.
Yeah. Yeah, like there's also other things. Like I don't, I guess the doc does say it a bit. If I remember it correctly, like when 301 was initially used,
Mm-hmm.
it like when you hit a URL, right? Like when we came here, we said get. We could put post, we could put other stuff. But if I remember correctly, I don't think 301 preserved it, right? Like I think it always like sent it to a get. Like so if you came with a post or maybe post word, but like a puts or a patch or something like that, it wouldn't go give it, your browser wouldn't send that again to the next URL. Where I think the reason of like doing another one
Mm-hmm.
like 308, and the same thing with 307 versus
Is,
302.
isn't it up to the browser, like how it would implement it? So if like a 301 just says, oh, this resource has moved, here's the new address, and then it's up to you what you want to do with that?
Well, yeah, I mean, it is up to the browser. I mean, this is a convention. Nobody's going to hold a gun to your head and force you to code it this way. But
Right.
I think the convention that just people went along with was that, at least for 301 and 302, it didn't keep the method. And then people said, well, that's a problem. Like, we want to keep the method.
Yeah.
And my understanding, like, I haven't looked at this
Oh, right.
closely
So
for a while.
the 308, it does say that, like if a post was used in the first request to post.
Yeah, so 307 and 308 were supposed to preserve this. So they were similar to 301 and 302, but they were just like they fixed what some people felt as a problem.
Right.
And a lot of times when people use 302, for example, like they want you to use it again the next place. It's not a big deal, but if you have that case, then okay. So, anyways, like there's docs for these codes, and this is something that's you probably want to look at some point, and you'll probably look at it when you need it. Like how do I do this? What should I use, or something like that.
Right.
Okay. So we did the telnet thing. That's fantastic. So we're going to be the server, right? We're gonna do this stuff, right? We're gonna respond with this. We're gonna put some headers, right? You can see there's a lot of headers here, and then after the headers, we're gonna give a response, right? So let's do that. Okay. So we're gonna use this package HTTP. And let me just clear this, and I'm going to open up our main. Now, right now with the main, I have this hello world. But what I want to do is turn this into a web server.
Right.
And if I, in some ways, I mean, you could write this completely from scratch, work at a very low level, but Go provides this nice package, HTTP. So we're gonna use this. Now, it doesn't mean we'll always use this. Doesn't mean you should always use this. But like for the sake of what we're doing today, we're going to use this. So I'm going to need to import this.
Well,
I don't want to.
there are a lot of other packages that you might use that are written kind of on top of this, but there's not a whole. It doesn't seem like there's a whole lot of use cases for going below it to like write your own.
Yeah, so net HTTP is Go's built-in HTTP package is pretty good. There are some performance issues, and some people have run their own from scratch. I haven't bothered. Like I've created a bunch of Go packages, libraries, what you might say in other language, or APIs. I've written a whole bunch of my own that integrate with this. I found this is pretty good, at least for most of the stuff I've done. So I just kind of stuck with it. And there's utility in that somehow. Like if kind of like a bunch of people make extensions to this common library, you can just like grab whoever's and fit them together. Like there's a bunch of my packages that are apparently popular. But anyways,
yeah, I think it's the idea of like if there's a common something actually that you showed earlier when you were typing out and you said, oh, I didn't follow my pattern. It becomes obvious if you're not, and so following the pattern, it also becomes intuitive, I think, and that's maybe.
Yeah. So I've added net HTTP from there, and I think like if you're not familiar with the package, usually what I do is I just go the examples, and Go is pretty good at adding examples to them. And like later on, maybe in a future episode, we can go over like if you're writing a package, how would you add examples to your package? So I'm going to click on this. It's going to take me a whole bunch of examples. Okay. So there's a whole bunch of stuff here. Might not be obvious which one. Like normally I might just click on all of them and try to figure it out.
Yeah, we're probably like, because we've already talked about this, we're going to do we want to do a get, like we want to handle a get at some point. We want to handle a get. We want to handle a post. We want to handle our own custom one, and we also want to serve something, right?
Yeah. So
what did you click on?
Well, I was going to click on this at first,
Yeah.
but you wanted me. It sounded like you wanted me to click on handle, so I
Oh,
clicked
I
on
was just
handle.
saying, like, we want to handle some stuff,
Yeah.
like maybe both of those.
So I'm gonna I think do. Mm, I'm gonna do this one. I think this is probably a little
Listen
easier
and
for
serve.
people.
Okay, yeah.
Yeah. So I'm gonna just copy and paste this.
The example's kind of interesting actually because it's a little more. There you go. Yeah, it's a little
Yeah.
more complex than you necessarily need it to be, but it's
Yeah.
pretty
Yes.
it's pretty typical too.
So I'm gonna try to like keep something now.
Okay.
This. So let's kind of like I think like dig into the. Actually, yeah. Let's dig into this a bit.
Okay. So even in the example that you're looking at here, it like you clicked on listen and serve, right? But it shows right above that handle.
Yeah. So
Right.
I'm gonna like probably ignore that one. Just let me bring up the code for it. So I'm just gonna go to the definition. There we go. Listen and serve. By the way, like this TLS version is basically the like HTTPS. We're not going to do that, but just for people who are kind of curious. So we have this function, and it has two parameters.
We're not going to do that this time, but next time we should probably do that because one of the things that I've noticed is like I think one of the worst habits of I would say like hands down the worst habit that I've seen in any presentation ever is, oh, don't actually do it like this, but I'm just going to show you this. You wouldn't really do it like this. But then like if you're speaking to somebody who already knows this, then that's fine. But then they don't need to even listen to the whole talk, right? But if you're speaking to somebody who doesn't know this, then it's probably important to show how you would actually implement that. But for right now, it's not going to help us to get the basic concepts.
Yeah.
Right?
I mean, like when I create production systems, I typically actually use this, and the secure stuff is handled elsewhere.
Right, because you might actually be behind a secure network already, right?
Yeah, so I usually do something a little more complex. I mean, like I usually code things so you could use this if you wanted to. I just structure my systems a bit different.
Okay, but so listen. All my point is that we'll at some point we'll do another one where we do take a look at that in like handling certificates, for example, and dive a little bit deeper into that, but and maybe link to that once we have this up as a video.
So I'm just setting up some code. I'll explain this in a bit.
Okay.
Let's just do that. Okay. So I have this function, listen and serve, and the first person's parameter is the address. Now, if you remember back to our URL, we had this, and remember when we did the telnet. I got rid of it. Let me. Oh, there we go. You see that 80, right? Like this URL. There's actually like some stuff kind of secretly there, some information. Technically, there's a port. Like remember, I said like the port for the TCP port for HTTP is 80. If in URLs, right, and there's different kinds of URLs. We haven't shown them, but like besides HTTP, you can actually specify a port, and you could put. Let me just make it a little smaller so it fits. You put 80 right there.
Right.
And what happens is that for each scheme, right, potentially there's a port defined for it. And for HTTP, it's 80. And if it's the default port, you don't even have to put that, right? But like for us, what I'm doing in the code, I'm using a different port than 80. I'm using 8080. So I could put that. And basically what this says is it's kind of like saying this, right? The reason I'm doing this is on a lot of systems, ports below a certain number, like it includes port 80, are guarded, right? You need special access to access them. And because I don't want to have to bother with that, when I develop, I'm going to do it on port 8080. It's quite common when people develop backends writing servers is they don't do it on port 80. They do it on some other port. And then when it goes to production, it might run on port 80. Right. So I've done that. And this is the syntax for it, right? Like I'd say, we're going to run on port 8080, which is basically like doing this, right? I'm going to have it like that. And it's just for development. So you can see here's this constant. Instead of hard coding it in here, right? I'm using this constant. to do that.
Mhm.
Now what I'm going to do, in their code, they kind of did something that was a bit awkward. I'm not going to do their little trick because I think it's confusing.
Like they wrapped the log fatal around it.
Yeah, they did that. They also put nil here. So I'm actually, let me just comment this out. We're not going to, I might uncomment that later, but I want to focus on just the web server. So we're doing listen and serve, and listen and serve can return an error. So I want to check that error. And if I get an error, the way I see if it has an error or not, I see, is it nil? If it's nil, there's no error. If it's not nil, something's happened. And the way I'm handling it is I'm going to panic. And normally you wouldn't panic. Normally you would do something like this. But with listen and serve, it's a little different in that it's really the only thing that's running. And for this specific case, you might panic.
Yeah.
But most errors you would not. Most errors,
because a panic is just going to crash your program, right?
Yeah, it's going to crash.
And so in a lot of cases, if you want sort of like some sort of error handling, but you want the show to go on, then you're not going to want to panic and crash your whole program. But in the case of this, which is a web server, if it is unable to serve, then it might make sense to just crash it.
Yeah, exactly. So what I've done is, this could be hard to see.
Well, it wasn't that bad actually.
Yeah, it's pretty long. So I've done a printf, and I wrote some text, error,
something bad,
and then something bad happens with the web server, and then I put and that's the one from here, right, which came from here, right. I have that there, and to make it actually show up in the string, I need to put a %s or something, right?
Yeah.
And if there's an error, it'll just give me information about it. It'll tell me what it is, right? And this is a generic way. You can do much more sophisticated.
Yeah.
You can do much more sophisticated things. For this particular case, I don't think it's important. Technically, for listen and serve, you could panic on it, but I'm just actually we'll do this. We'll just keep that in there. Okay, fantastic. So this is this handler. I haven't done that yet. So what is a handler? Now, there's kind of a cool concept you have with this HTTP package. It has something called handle. So here's our function definition again. We took care of the first one right here, and then handler we need to do. So let's look at handler. There's a lot of text. Normally you would read this, but the key is that handler's an interface, right? And well, what's a handler? Handler is something with this method, right? It has serve HTTP. Let's do this like kind of like the way that's more kind of straightforward with the way the code's organized. And there's some ways to make this a little easier to use, but we're gonna do it. So what we're gonna do is create a handler. So I'm gonna create my handler, and this is just struct, and I don't actually care what's in it, right? There's going to be nothing in it actually. I just need a type. Right? I need to make my own type. There is a way of doing this so you don't have to do this. We can cover that later maybe, but I just want to keep things simple for now. And then what we want is that
I'm making them more complex.
Yeah, well, I think like it's like where's the complexity, right?
Right.
And then I'm gonna make a method on this, right? And that's what kind of like this says. A handler is an interface, and interface is some type with this method, right? Okay, so let's how do we make a method? Well, I have to like have that same name there. And I'm going to call it receiver, right? So you just kind of put that for methods. You could actually call it whatever you want, but I just usually call it receiver. And then I need
that's what it's called in Go, right? Like that is actually a receiver.
That's literally the name for it.
Yeah.
Hopefully you can still see that. So I have this, and what I need to do is we're going to give that a name, request. This is kind of scrolling off. And then with writer, I'm just going to call it W. Is that too small? That's probably too small.
No, it's fine. It's fine. Yeah.
So I have this method here, and okay, so that's there. So serve HTTP W request, and I've just basically like given my new type this. So what am I going to do? Well, let's just see if this works, right? So let me just like stick. This, I don't know if you can hear the noise outside. I don't know why someone's so noisy outside this time of the world. Actually, I should say this.
So here you're just printing to standard out.
Yeah, I mean, I just want to see if this works, right? Did I get
Yep.
everything working? And it's like, okay,
Well,
no,
let's walk through what we expect to have happen here. So go up a little bit more, please, if you don't mind,
no problem.
before we hop to there. So we see we have, you've declared a const, which is your HTTP address, and you're only really declaring that so that you have it somewhere so that you can then pass it into the listen and serve function. And so you're passing that in. So the first argument that listen and serve takes is the port, which is 8080 in this case, and it actually takes :8080, which may be of note or not. And
just like the colon there.
Right. And then you have handler, and you're passing in handler. You looked at the method signature in the docs, and it said handler, so we're just following that convention because that's what it is. But then you actually decided, okay, well, now I need to define something called handler that I'll pass in. And then, so if we scroll down a little bit,
so
then here you're my handler.
Right. And I haven't actually like created the variable yet.
We haven't created the variable yet. So that's what we're going to have to do. And it's going to be handler is my handler, right?
Yeah. And
okay. And so here you're saying the var handler is of type my handler. And if you look down, my handler is the struct that we created. But then when you go down a little bit below that, there we go. So you said func receiver my handler. And so what that means is this method serve HTTP is a method that a method on my handler. So you have a my handler called handler, which has this serve HTTP method that you've just defined here, which takes a W, which is of type response writer, and a request, which is a pointer to HTTP request. And then it's just gonna print to standard out what you got inside the print line.
I think maybe there's going to be some problems, but like this is how I kind of develop, right? Like I'm just going to try it and see if this works. If it doesn't work, let me try something else, right? Okay. So because it's a single file, I can still do go run. Normally, like what people would do is they might do go build, and okay, there's a problem, and then you notice your problems and you fix your problems. But you would do that, and you create a binary, and you'd run that binary. But just because there's a single file, we're going to keep it simple. So let me. I think I.
So it said undefined response writer, right?
Yeah, I mean, like one of the problems with Go when it does its documentation is because you're in this HTTP package, it doesn't need to put .http dot in front of its type. So if you copy and paste, you miss those. So I did do it to the request. I put HTTP dot in front of it. I need to do it here too. But
so actually, a question that might come up here is why do you have HTTP response writer is not a pointer to, but request is a pointer to HTTP.
Good question. So if you go to request, it's a struct, right? And sometimes when you deal with structs, like if you didn't put a pointer to it, you would copy it. And sometimes you want to copy it, but sometimes also you don't want to copy it. And to not copy like the struct that you had, like it's an area in memory, just use a pointer.
Right. So if you'd want to copy it, if you didn't want to mutate it, for example, maybe.
It could be that. It's also like if the struct's not too big, it might not be a big deal to copy it.
What's a good rule of thumb? Should you be using pointers if you're not sure, or should you be not using a pointer if you're not sure?
If you're not sure, use a pointer. For most of the cases, unless you're trying to stop writing. But like probably if you're not sure, especially for the receiver, right?
Yeah.
If you're not sure, just use a pointer. But I tend to be picky, like when I do and don't. But yeah, it's just if you're not sure, just use a pointer. You'll get it wrong sometimes, but
you'll probably notice it as well if you do get it wrong.
Yeah, test your code.
As opposed to you might not notice it as easily if you don't use a pointer.
Yeah, sometimes you get weird errors, like maybe you create a method that you want to change something, like for example, change
update address. Change
and then you didn't pass a pointer. Well, what you did is copy it, and you changed the copy, and then the copy disappeared. And it's like, okay, why doesn't it work? Well, because you don't have a pointer. Okay, so we looked at request and we saw that was a struct. Fantastic. When we look at response writer, we see it's an interface. An interface is a type of pointer. It's a very kind of complex pointer, but it's a type of pointer. So we don't need to say pointer to that in that case. Okay, so we have this, and let's run this. Let's see what happens. Go run main. Okay, so I had that begin in the beginning. And
but you don't have you don't have the output yet because nothing is hitting your endpoint to be handled.
So I might be able to do it from this web browser. Let me just check. So I'm going to type local host port 8080. Let's just see what happens. Cannot be, no, okay. So I don't think I can do it from there. That's fine. So what I'm going to do is I'm going to open up another console.
But that you're being unable to do that, I think, has more to do with your development environment and operating system than anything else. Yeah.
Yeah, it's a thing with my computer.
Yeah.
People wouldn't get this in general. So I'm just going to do telnet to try this out. So let's try this. So I'm going to do, so before it was www.example.com. I'm going to do localhost, and localhost means my computer. And I've written this program on my computer. It's running there. So I'm going to connect to my computer, and I'm going to go to port 8080. Right? Why? Because I had that in the code. And we'll just type get http/1.1.1 host local host connection close.
And you got a 200. Okay, nice.
Fantastic. So I sent that request. Here's what I sent. It's a little different than we saw before. Get, instead of like /cherry.html, it's just / like the root page. Same version, host change. I got local host. And then I get a different response. It's not 404. You notice that? So before we had 404, now we have 200. Okay, right?
So now for this, of course, is the client, right? The client side. You're acting as a web browser and calling that. So we wouldn't expect to see anything printed to the standard out here because of the way that you invoked that call. It was like a print line, which would be server side, right?
Yeah. So if you see, like, here's the server running this is the client, this is server.
Yep.
I had a begin when the program begins, and then if you hit a URL, it wrote this. You can see inside server HTTP, and you can see here, like with our response, like there's no content, there's no HTML. Where's the HTML? And like we haven't gone over this yet, but if you notice, there's content length 0, right? And if you think about it, I'm just going to kill this with Control C. If I press Control C, I can kill that program. If you look here, I didn't send anything to the client, right?
No.
This thing W, this lets me send things to the client, but I didn't send anything, right? So let's add that, right? Let's add something with Go. But
you're going to have to do like a different type of print, like a format print.
Yeah. So with Go, I'm going to look up at something else. There's another package called IO, and in this, I have something called writer. And a writer is anything with this. And
so this typewriter is not a typewriter.
Yeah.
That's like the stupidest joke ever, right?
Yeah.
But I don't know why I always find that funny.
No, yeah. So if you were to, where'd it go? Oops, this is the wrong one. If you were to click this,
response writer is a type.
It actually has a write method.
So it does satisfy the writer interface.
So that means it's also a writer, and that means any function that uses writer can also use that. And that's like the magic of it. That's one of the things I love about Go. This kind of like interface-oriented programming. There's another name that it's not quite this, but there's something called duck typing, right? If something looks like a duck and quacks like a duck, it's a duck. And it's got some edge cases that I wish the creators of Go would fix, where it's not true, where it doesn't do duck typing. But I like duck typing a lot. Python also seems to do this.
Pretty much what you're calling duck typing in this case is interface inference, you might say.
Maybe.
So you don't have to explicitly state that this implements this interface.
Yeah,
it's
exactly.
It's implied.
Yeah, like if you're using C# or Java or C++, you end up having to create adapters that look just like the other thing, which I think is silly. Okay, so what I've added now, I've added this format.html. fprintf, right? So here, like if I changed a bit, I could have left this as, we did printf. I could have done something like this, right? If I want, I'm just, it looks more complex because it was print line before, but I want to use printf
formatted printing, right?
and then fprintf, just so you can see the similarities.
Yep.
So what fprintf, it's just like this, and I'll just kind of like, I'll just put something else. Hello from the server.
Oh yeah.
And what happens, it has a first parameter and the thing it goes to. So what this says is that, actually I can do one other thing. Let me make this even simpler. Let's do this. I think you can do this. So I'm gonna, and we'll just put that back. So print line and fprint line. I think that'll work. Here I send it to the console, right? So when I run the program, it's on the console, and you see this message, right? You see that message there. This is going to get sent to the client, right? And implicitly, there's the way this works is behind the scene. There's another parameter in the beginning. This actually sends it to this OS standard out, but like it kind of hides it from you. It sends that to the console, right? And this sends it to the client. But they work very much similar. So let's run this and see what happens. Let me just move that up so you can see that. We're going to run. Okay, begin. So it's begun. Excellent. Now we're going to switch the other console, which is here. And I'm just going to clear that. And we're going to run this again. So I'm going to type get http/1.1 host localhost connection close, because I only want to send one request, and enter twice. Okay, good. So what do we have now? So here's where the response starts. Let me just make that bigger.
You have a content length this time.
Yeah. So here's the response starts. 200 okay, right? Version 200 okay. It threw in a date, right? By the way, like a lot of times I think a web browser, does it send a date? Maybe not, doesn't matter. Here's another header. Yeah, thanks. Content length, right? And it's 23. What does that mean? Well, here's a body, and this should be 23 bytes. That's what that 23 represents. Like, how much data can you expect? Yeah. In this particular case, it probably didn't need to send it, but there are cases where you would need this. Okay, and it also has a type, right? Like, what's it sending? In my case, like this is an HTML, and remember, like HTML is that stuff with those kind of like funky symbols. Let me just kind of scroll down. Like, you had these symbols like paragraph, hello world, maybe I have bolds, hello. Like it has those kind of like, angle brackets, or less than greater than symbols that it uses brackets.
Isn't bold deprecated now? Is it? I don't know. It might not be. Never mind.
Depends who you ask. There's different ideologies, let's say, with HTML. So with this, because it wasn't HTML, it doesn't say HTML, right? Like if it was HTML, this instead would be, it would be text HTML rather than text plain. Right. But because I just put, normal text, I just wrote, this. Yeah. It what happened is that Go kind of inferred this was text plain. Normally, I might have to specify this, but because the Go package is pretty sophisticated, it kind of figured it out. Oh, you're using text plain. Right. And I'm also kind of assuming you're using UTF-8. So there's different kinds of text. Text isn't one thing. It's many different types. So it's saying it's plain text, right? It's this encoding of text. And then the connection closed, right? It says, yeah, I'm going to close the connection. It just kind of lets you know. And then here's what it sends. And like this, you can see, let me just kill that, and I'll open it up again, and I'll search. Bam, that's exactly what I sent. Yep. Right? So that's pretty cool, right?
It is pretty cool, yeah.
Let's try to open up a browser. I think I can probably, if I do it from here, I think it'll work. So let me just go here. I'm going to run this again.
Run this, yeah.
Okay. Now I'm going to open up Chromium, and I'm going to go to http:/localhost/8080 :8080. Let's see if that works. It might be kind of slow the first time I open. Oh, there we go. Come on. It's going to work. Oh, work. Excellent. So I'm just going to make that a little bigger so everyone can see it.
Hello from the server.
Yeah,
there it
cool.
is.
Yeah, and remember, like the reason I have to open up the web browser this way is just because the way my computer is. You probably don't have to do that. It's just I have a weird computer. So that's pretty cool. So we got it working. So what happens if we wanted this to be HTML, right? Okay, let's try that out. Ooh, look at all those weird messages that Chrome sent. Okay, so actually let me change the comp sci. Let me do that. Okay, good. It's weird. Okay, so I'm gonna kill that. And you can see, by the way, like you notice, like I did it from Telnet first, and then I hit it once, and then I did it from the web Chromium, and I hit it second time. That's pretty cool. So let's code this. Now, Go is also sophisticated enough. If I put some HTML in here, it'll understand that too, right? So what I'm going to do is instead of actually, first let's keep it simple. We'll just do some simple HTML. So I'm going to put. I think you'll recognize this. If it doesn't, we'll change it. So I'm writing some HTML. I'm putting hello, and then we'll do world, and I'm just going to color this color red. Okay, so let's do our telnet again.
Did you run the server?
Oh, thank you. I did not. Good. Oh, we got a syntax error. What did I get? Oh, I know what it is. I had double quotes. Right.
Oh, yeah,
so the string starts with a double quote, but HTML also uses a double quote. So when in this case, what I would also do is I just change the style of the string. Go
to a string literal.
Yeah, it's a different way of doing it. So if I use backticks, what happens is that it kind of it ignores everything inside. Like it doesn't conflict, right? So I can start the string with a backtick, and then having a double quote within it is not a big deal. So I think that should work. Okay, so oops. There we go. So let's run that. And if it doesn't work, we'll just try to debug it again. It's very common. Like you miss something, you forget something, doesn't work. So I've started it, and you can see there's the begin right there.
That's why it's good to not try and build too many things without running it, because otherwise you end up with like a lot of really difficult to troubleshoot errors. They can be as simple as typos too, right?
Oh yeah, I mean that's usually the type of errors I have. I misspell something. I type like something's supposed to be uppercase, I put it lowercase, or I missed a key and I typed it wrong. Okay, so we're going to come back here, and I'm going to connect to it. So I'm going to do the same thing. I'm going to hit that and get /HTTP/1.1. Again, we're just typing HTTP by hand. Connection close. Bam. So you can see in the body, right? And like how we know it's body, it starts here. There's that first line. There's a bunch of headers, and then there's a space, right? And after the space, a blank line.
A line break.
Yeah. That's how you know the division between the headers and the body. That's just the way HTML or HTTP is.
Yeah.
And then you look here and you see, oh, it's what we have. It's that HTML code. Now you also notice that the Go package is smart enough to figure out it's HTML, right? So you have HTML there instead of plain text plain, which we.
I was gonna say that, like, saying space. It's actually correct. It's just that in the domain of computer programming, when we say space, we have a very specific meaning. And so rather than say space as in, writing double spaced, for example, we're using the line or like the return as opposed to space, which would mean like the non-breaking space.
Yeah, that's a good point. It's something that could
we could say breaking space, but I don't hear that very often.
Yeah, I mean, like it's those little things that can trip up someone when they listen to like us talking. So it's good you point that out. Okay, so we've seen this from Telnet. What I'm going to do is like run Chromium, right? I'm going to run the web browser. So let me just.
So the browser will almost definitely render this differently from what your console is rendering it.
Yeah. So if you look at this code here, so I start with a paragraph. So okay, it should be in a paragraph, and I bolded hello, right? So I expect to be bold, but I also wrapped world in the span tag, and I gave it color red. So that's my expectation. I might have typed something wrong. There could be some mistakes. And I just run it to see if it worked. Like maybe I got it perfect one shot, maybe I didn't. If I didn't, I go back and fix it. And that's common, right? So let's run that.
Looks pretty good to me.
Look at that. Look at that.
There you go.
So it's in a paragraph. I got
I don't know what kind of text that is. Like what what font is that?
yeah. I mean, like you could adjust the font. You could do all sorts of other stuff with HTML to make this look pretty.
Yeah.
But I mean, it worked, right? And that's pretty cool. Okay, so we got, what do we have now, right? Like, so
we have a GET request.
Yeah. So we start this program. We first want to see if the program works. And we did that by just doing format prints line, right? I just want to get something working. And then like we want to set up a basic web browser. I want to say, okay, does the web browser work, right? Fantastic. Like we've just demonstrated our web browser works, but we had an end goal, right? Now we got to go to the next step. Okay. So I'm going to close this. I'm going to clear that because it's pretty messy. And I'm going to go back here. And the web server is still running, so I'm just going to kill it. Okay. So clear and main. Okay. That is fantastic. So what I'm going to do, like we did HTML, I'm going to just remove the HTML just because I don't think we need it right now. And what we wanted to do is we wanted to handle these different kind of requests. So I'm just going to give myself some space. So in HTTP, I kind of cleared it. I'll do that later. If you remember, like when we did the request, I did something like HTML, HTTP /1.1. Oops. Or in the case that we just did, it was a bit different. So it wasn't /cherry. And I had something.
Localhost.
Yeah. So they're very similar. Like maybe it's useful to see those together. Like this is a bit different than this.
Yeah.
And then this is a bit different than this. So those things change between them. But a lot of the stuff was the same. Right?
So the forward slash there, all that's saying is that's the end, right? Like, so whatever the address is, so in this case, localhost, you're getting what's right there. You're not trying to get what's at localhost /cherry.html, that specific file, but actually rather just at the home or the root.
Yeah. So this request there corresponds to this, right? So this I took straight from here.
Yep.
And this I took straight from here, right? Okay, so what does this request?
And your protocol is, of course, the same, the HTTP.
Yeah. And so what does this correspond to? So I type HTTP : / and that's that, right? Just like that was that. And now I take this, that corresponds to this, and then I take this, and it corresponds to that.
Right. And now you don't actually need to have that / but you can, right? Like it's without it, it's assumed that that's where you are.
Yeah. So your web browser will make that assumption, but with the URL, it is you do actually need it there, right? So it's usually that the web browser is kind of doing a correction on you, and when you come to this, right, you would have to put the /. You can't do, for example, this won't work. This probably won't work. It shouldn't work. So it is there. And you're right, like people often write that, but it is really the web browser that says, oh, you made an error. Let me put one there for you, right? And sometimes I think some web browsers even hide that from you, but it is really there. Okay, so we have this. That's fantastic. And you notice with both of these, we did get, right? And if you remember from last time, what we wanted to do is we wanted to be able to handle other things like post and scream and, puts and whatever else. Okay.
Yeah.
So I think for a first step, we need to get access to this method. Like how does a server see that? So how about this? What we're going to do is we're going to change the server. And what it's going to do is going to figure out what method is being sent. And it's going to give it back. It's just going to give it the response, right?
Good idea. And so actually looking at exactly this, like maybe we go back for a second, looking at exactly what we're just looking at. My first question is going to be, well, how are we going to figure this out? But we already showed that, well, when you're sending this request, you're saying, this is the type of request that I have right here. I'm saying get, this is a get request. So I'm explicitly stating the type of request. All I have to do is read that.
Yeah, I mean, the client, like the web browser, is telling it, right? And the server's going to get the information. Now, if you were kind of using this, if you click on a link, or you type something in the browser's location at the top, I don't know if you can see it like this. That's a get. That's always going to be a get. You have to do posts in different ways. Like if you create a form within the HTML, we can do that. You can either do a get or you can do a post also. And we're first going to try to do these by hand. And then what we're going to do is just, do it with like HTML and other stuff. But like this is how you would like develop this, right? And create this.
Yeah.
So we want to show like, what it's actually like. Okay. So in Go, let me just go to the docs, and we're going to go back to the Go HTTP docs. Okay, good. So we're here. I'm just going to go to the top, and I'm just going to go handler. Where's handler? Type handler. Okay, great. Oops, not great. Okay, so we have this. Has two parameters. Now, the response writer is what you send to the client. The request is it kind of represents like what you wrote, right? Like this. It represents this. Right, oops. It represents this, right? It's how Go kind of like gives that to you. It could, like if you were writing something much more low level, you would get this directly. You would get this as like a string or maybe in an array or something like that, and you'd have to like read this and figure like you'd have to be able to read
parse
headers.
It yourself, right?
Yeah, you would have to parse yourself. But Go does that for you, and it conveniently puts this into this struct, right? And for example, like it gets this little first part and it sticks it here in method, right? And of course, there's other parts too. Like for example, this, just the HTTP part, it puts in protocol, and then this number here, it puts into proto major, and then this part here puts in the proto minor. Like it does a lot of stuff for you. You can get like a whole bunch of headers through this. If you had a body, right, you can get it through this. Like it basically like puts in a struct and gives you some funcs and some other stuff or methods to play with it.
And a lot of documentation around that would probably be worth reading at some point, but maybe not on the stream.
Yeah. So what we care about is the method. That's where like when Go reads that stuff, it puts it. Okay. So
we know that's just a F-type string, so that's just going to say what type of method it is, right? So we can just read that.
Right. So what we're going to do, we're going to two things. I'm just going to for now print it to the console because I want to see on the server.
Yeah.
And
that's going to be your request method. Yeah.
Yeah. Actually, I'll do.
So an interesting thing here, like you don't actually have to interpolate when you're doing print line. You'd have to do print F, but like you don't have to interpolate here. You can actually just remove the %Q, and it'll still write that in there.
Oh, right. Actually, I shouldn't put %Q. I should have done this.
Well, there you go. Yeah. But you could do print line and then not have the %Q at all.
Yeah, let's do that. I think you're right. That's simpler. So I'm going to do that, and that's going to send it to the console. But I want to send it to the client, right?
Yeah.
So I'm gonna do F print line, right? Yeah. And actually, what I'll do is I'll just copy paste. We'll just do this. And like maybe you wouldn't do this way in production code, but I mean, I think it's fine just to keep this simple, right? Like what I probably
we're at the point right now where we're just trying to get something to work and see that we have inputs and outputs happening on both ends, right?
Yeah. I would probably like write this to a buffer first and then send the whole buffer to the client. But because we're just trying to get this, see if it works, we're going to do this. Okay. So what I've tried to do is we still print this when it hits the serve HTTP method because I want to see if it hits it. And then if it did, fantastic. We're going to print to the console on the server's end that it got, what method is a get, a post, a scream, whatever. Scream is something we made up, by the way. But it's going to send it to the client. And my expectation, since this isn't HTML, it's going to figure out its text.
So I have a question. You said you'd probably write it to a buffer first. Like in this actual case, if all you're sending is the request method, would you write it to a buffer?
No, because it's just one thing. If I was like constructing like a whole bunch of like text or HTML, I would write that to a buffer first and send it all at once. Me writing to a buffer is quick. Me sending it to the client is slow. So I want to like,
make sure that it actually works.
Yeah, like send it all in one shot. Like it's easier. Or it should be, I think, more performance if the assumptions I'm making about how they coded this is correct. They might have done something sophisticated on the side, like they might have add buffering. I just don't know about it, but I would probably write it to buffers. Okay, so let's see what happens when we run this, right? I'm gonna go, I'll just clear, and I'll do run. Okay, so go run main. Okay, so it's begun, fantastic. Now we're gonna go to the other console, and I'm going to be telling it again. So we're going to do that, and we're going to type get. Actually, let's just do that. Oops. host, local host, connection, close, enter. Bam. Okay, let's see what happened over here. I went inside the server HTTP method and HTTP request method get. And that is what I typed. Fantastic. And then responded, we have the HTTP / 1.1 200 OK. We got a bunch of headers. It did detect its text. Okay, so that's the Go library figuring out. And then here's what I wrote: HTTP request method get. Fantastic. That's what we expected. So that seems like it's working. Let's try another one. I'm going to clear this just so we can see it. I'm going to try Scream and see what happens.
Okay.
So Scream.
So in this case, this is, I think this is kind of neat, and it's maybe not that neat when you think through it. It's pretty straightforward, but we haven't implemented any sort of special method or any other, any custom methods, like Scream, for example. We haven't implemented that yet.
No. So Scream / HTTP host, local host, connection closed. Okay. So inside server HTTP request method Scream. Look at that.
So our program already knows what kind of request method this is.
Yep. So that was the server end. I could see the server end was working. That's what this console has. And over here where I ran Telnet, you can see like, here's my request. Yeah. Instead of having get, I have Scream. And HTTP / 1.1 200 OK. Same headers, recognizes text.
And really, we know that if we look into the HTTP package or library, then we will see that it has a way to parse the incoming request, and it picked the method from the string that we typed in here, Scream. So whatever we put in there, it would know.
Yeah. So whenever it gets whatever's here, Go will the request, right? And where did the request come from? When your serve HTTP is called by the Go package, it'll pass a parameter here, request, and request will take this string and it'll put it in this method. And it doesn't care what it is, right? You can put anything there. It's going to put it there, right? And like, why did this work? Like this just worked. 200 OK. Like, why that work? Yeah. Well, like, look at the way we code it. So I'm going to kill this. I'm just going to clear, and let's look at the code. So what happens? We come here, and it's like we don't really care what method is. Like it works no matter what. Like we didn't say don't work for Scream method. Like we could have, right? But it's like because we didn't say to work or not work for the method, all we did was no matter what it is, we print this. No matter what it is, we print this. No matter what it's printed, we print it no matter what method you send. That's why it works, right? Yeah. When you create, let's say you're creating an API like over HTTP, you would want to look at that most likely. You wouldn't care what it is. But because we just kind of like, we're trying to figure this out, we're trying to get this going, we're trying to see if it works, we don't care yet, but we will.
So we might actually even, right, you're right. We don't care yet. So we're just handling anything, and all we're doing though is saying this is the method that it is, right?
Yep.
And so that's kind of neat. So if you were going to build an API, you might start with a default method, like a default method handler that would just say, sorry, we don't handle that. And then you could explicitly handle anything that you do.
Yeah. So let's do that. Let's do that. So what would I do? So I'm just going to leave this text in for here for now. Sure. I'll move it around in a bit, but let's do this. So we have this, right? We have request method. Yeah. And request methods tells us the method. Is it go? Is it post? Is it patch? Is it put? Is it scream, punch, kick, whatever? And I want to do stuff depending on what it is. And
now, can I just stop you for 1 second? Because I think you've said some very interesting words. Scream, punch, kick, all of these things. I've noticed something about them. Okay. They're action words, doing words. They're verbs.
The verbs. Yeah, you're right. So the methods in Go, the convention people have, and there's no one to force you to do this, but the convention is that the methods represent verbs.
Well, it's not an uncommon convention, really, and I think that's the same convention we see in HTTP, isn't it?
Yeah. I mean, exactly. Like it is the HTTP convention.
Yeah.
Scream, scream, kick, punch, or stuff we made up.
Yeah.
But get.
But we're following the convention of exactly. Let's use the verb here.
Yeah. Yeah, and it's just a decision we're making. We're going to follow along. Like, it sometimes helps if you follow the convention. I'm not saying you always should. Like, some conventions are not that great, and there's reasons why you might not use it, or maybe you don't want to.
Well, you
But not,
definitely don't have to, right? But
yeah,
one reason I think that's sort of intuitive and makes sense is for the same reason that, you know, when you were writing out key value, and you said like first banana, second orange,
yeah,
third, but then instead of third you said cherry, and you're like, oh wait, that's not following this
yeah,
convention. Really, it's not following the same pattern. It just makes if you're not following a pattern, then there's some confusion, some chaos,
yeah.
if you will.
It's diverges from what other people expect, and sometimes you don't care what other people expect, but sometimes it's useful. Sometimes it can help you. So okay, so let's do different things depending on the method. There's different ways of doing this to Go. I usually use a switch when I do this. Like, you could use an if else, but switch I think is a little nicer.
So I tend to agree, but I think the reality of it is that the compiler doesn't care which you use. It's going to
Yeah,
optimize it either way, the same way. And so it's really just like it's interesting because in some other cases, Go doesn't have multiple ways to do the same thing, but in this case it does, and it's really just human readable syntax, right?
yeah,
Syntactic sugar.
yeah, exactly. It makes it easier to read. So what are the different methods, right? So
Mhm.
one of them is get. Now, if I wrote this, it wouldn't work. Like, the case matters. The convention in Go is it's capitalized, right?
Mhm.
So I could have that, and then I'll do something. I'll fill in this code in a bit,
Yeah,
and
and then maybe
then
we'll have a default.
yeah. So we can do post, and then to do. Oops, to do, and
Might want to
then
fix your
thanks. Yeah.
spacing there.
And then we'll do scream to do, and then what happens here to do? Okay, so this code will run through it, but it doesn't actually do anything. So let me, for now, what I'm going to do is that I'm going to print something, right? And what I'm going to do is I'm not going to do this because I want to control what it sends to the web browser. And I'm just going to, so format f, oops, I spelled that wrong, f prints line. We want to send it to the client.
So it's kind
Okay.
of funny. You said, you know, some people say fumped, but you say format.
Yeah.
I go both ways, but when it comes to print line, some people say println, and
Oh,
I really don't like that for some reason. It
yeah.
bothers me.
Yeah. I mean, like, when I'm
I
speaking in
like print
English,
line.
yeah,
Yeah,
I'll just say it in a way that's easier.
yeah.
So I'm going to make these lines look a little different just to kind of prove to ourselves that it's like, uh, this is get. So the
Mhm.
next one won't be this is post. I'm just going to copy that to make it a little different. Post I did. This will be I
Ah.
screamed. Yeah, actually. Okay. And then here,
You can probably remove the to do from
yeah,
screen since you've done it.
yep. And then I'll
Here.
just copy that. And here, what I'll do is I
Well,
will say,
here's an interesting thing. What I would like to see here is an error,
okay, let's do an error.
right? But
Um,
maybe not yet. Maybe we can look at that and see what it says. But it'll probably show us, in this case, it'll probably give us a 200 because nothing went wrong. But
yeah,
we want to change that to a 400. But let's see if that works. Anyway,
okay.
let's not get
So
too far
I'm
ahead of
gonna
ourselves.
leave it like this.
Okay.
Actually, yeah, I'll do it. So what I should do,
Yeah.
I should add a return after all these, because like when I run the get, I don't let
Otherwise,
it
it's going to
keep on
fall
going.
through.
Yeah, it'll just keep on going, and there's nothing there now, but it's a way you can kind of get bugs sometimes, like because maybe someone adds some code here and you didn't expect it to keep on going, and it does.
Mhm.
So I'm just going to add returns after all these. So this is going to just end. Okay, so I have this code. So what do I expect? When someone calls this, again, it's going to say inside server HTTP. It's going to say the methods, and it's just going to go to the console, not to the client. And then based on these methods, if it's a get, it'll write this. If it's
Right.
a post, it'll write all this. If it's a scream, it'll write this. And then if it's something else, it'll write what? Right.
Yep.
And this, like you pointed out, Drew, it's not going to be perfect. We're going to have to come back and fix this, but it'll let us see if we get this working, right?
Mm-hmm.
So I'm going to clear. I'm going to do go
Even,
run.
even this, like, it's a good first step, but we've also done 4 methods instead of, just one at a time, which we could have gone a little bit simpler.
Yeah. Yeah.
Kind of depends. And that's sort of a, depending on your comfort level type thing. There's not really a hard rule for how far to go.
Yeah. Good point. So I've run the server begin. Okay, so that was, we stuck that at the beginning of the code when it runs. So it's begun. So let's go here, and I'm going to write telnet localhost 80, 80.
80, yeah.
And then we'll just do get first.
So first you're establishing the connection, and now your connection's open. And then you're saying, okay, I want to do a get request. I'm already connected to this host, but I still have to specify the host, and then I'm going to close the connection.
Yeah, so I use telnet to connect to it. Ignore these lines because telnet just outputs that. I then wrote an HTTP request by hand. This is like what your browser sends.
Yeah.
And then, I hit enter twice. And then what happened is then the server sent me this. Right. The server sent me all this. And this last line here, the connection closed by foreign host, that's also telnet. So ignore that.
Well, it's interesting. Foreign host.
Yeah.
But that's the client basically, right? And that's because you have the connection closed. Is it?
So it was the server.
No, the connection. The server closed.
So in this case, the host would be the server. So it was because what happened is that when I sent this, I told the server, hey, I'm only going to send one request. And then the server said, okay, I'm going to close it. And that kind of like, this is what it's telling you. And then telnet noted it closed, right?
Yep.
Okay, so we did this and we did an okay. We did a get.
Yeah.
And then what did we expect? Well, I'm just going to kill this really quick. Let's look at our code. What we expected is if it was a get, it would return
this is get.
And what we get?
This is get.
Fantastic.
And it gave us a 200 okay. So we're happy with that, I think.
Yeah, in case of like this, it was the right thing to do.
Yep.
Okay, so let's try Scream. So I'm gonna clear that. Excuse me. Okay, so Scream /1.1. Getting good at typing this. Connection close. Bam. Okay.
I scream at you.
Yeah, it's just like what we expect, right? Like we'll just check just to show that. And you notice Scream, and that's the Scream there. Yep. And what we expect, it should do this. I scream at you. That's exactly what we got. Fantastic. Yeah. Now it also did a 200 okay, right? Okay,
which we also expect because that was the correct. Everything was okay.
Yeah. So let's run the server again because I shut it down so I can see the code.
Yep.
And we're going to clear that. Now let's do something else. Let's do punch. We're going to do punch. Okay. So we're going to run this and punch. We'll do that still the same because I don't want to change it now. Host, local host, connection, close, enter, bam. And, I'm going to just kill this just so we can see it. And what do we expect?
So what we expect here, because we don't have punch defined, right? We don't have any handling of a case. Well, we do actually have handling for the case punch. We have handle the default.
Specified. We have get specified. We have post. We have scream. There's no punch. So what happens? It goes to default.
Specified, right?
Right. Just like you were saying, it goes to default. And what's in default? What? Right? It worked, right?
Yeah. Now it did work, and it actually so far it works exactly the same way that the other things do. However, we get this 200 okay, and maybe we don't really want to send that because we don't have a way to handle this. Our default case should send back something like maybe either well, in this case, it's not really a 404 not found because we do have this path, but we don't have this method. We don't have the method not allowed, not acceptable.
Yeah. So
method not allowed might be a good one.
Yeah. So there's actually there's actually a response code, right, for this, right? Like, so you send a method that the server doesn't recognize, and you can send this. So this is a convention that's already established. If you
here's an interesting thing.
Yeah.
The method is known by the server, but has been disabled and cannot be used. Would this be a good case for a default handling since you wouldn't know that method? Is this deceitful?
So if you're going to handle it somehow,
Yeah.
you wouldn't return method not allowed. You would just kind of handle it. But in this case,
but I know it, and I'm disabling it, even though I have no idea what it is.
Yeah, so I mean, if you're disabling it, then I think it'd be method not allowed still.
Well, that's what it says right here, right? Like this, the request method is known by the server but has been disabled.
Let's see. The request method is known by the server but has been disabled and cannot be used. For example, an API may forbid deleting a resource. The two mandatory. Oh, okay, so I guess it has to be known. Well, I never use it that way. Okay, interesting. Let's we'll just use it for now.
Okay, sure. Well, actually, let's take a look. What is 406? Not acceptable. The response is sent when the web server, after performing server-driven content negotiation, doesn't find it. No, that doesn't. Okay.
I mean,
sure.
we can look through these, right? Like there's bad requests. This is generic, right? It's some error the client made, right? That's what you put.
But it says due to invalid syntax.
People don't always use it that way. So, like I said, these are conventions. What I've noticed now is just people just use this generic. It doesn't have to be invalid syntax.
Yeah.
Unauthorized. You don't have the credentials. Maybe your username.
Well, that's interesting. I've seen 403 a lot in the case of like an unauthorized. It seems.
Yeah, you're not allowed to. You don't have permission to access it.
Yeah. Unlike 401, the client's identity is known to the server. Okay, so that's interesting.
Forbidden, like you can't go. Not found is the famous one. We've ever seen that. Method not allowed. Not acceptable. The response is sent when the web server, after performing blah blah blah, doesn't find content. Proxy authentication required. Request timeout. Conflict gone. Length required. Precondition failed. Payload too large. URI too long. Unsupported media type. Range not satisfiable. Exception failed. I'm a teapot.
There we go. That was
actually a joke one year, but it stuck. We can return that, I guess. Misdirect request. Yes, I mean there's a whole bunch.
Well, we could also make our own if we wanted, right?
We could. So let's just use
407.
Yeah, whatever it was.
406, not 405. 405. Not allowed.
Let's use
yeah, that sounds good.
So what we're going to do in here is we're going to do that. Now with Go, they actually have a way to help you deal with errors, and I'm going to try to get that to come up. Okay, so what I'm going to do is I'm going to search for func error. So I kind of already knew this because I've used the package, but it has this method, and that's one of the things when you program. Like sometimes you want to do something, you might check to see if the library you're using has this method. Sometimes you code it yourself, but it's something, coding yourself is something you do more likely as you get more experience. So func error, let's look at this. So it has two parameters. It has the response thread. That's just like the server HTTP method, right? Like that's where we write stuff. And it has an error string. So it's some string I sent, and then the code. Okay, so let's use this. So I'm going to copy this.
Yep. And you're just copying that because that's the same method signature.
Yeah, I'm gonna tweak it a bit, but okay. Yep. So I don't need the type here because I'm using it. So it's the W.
The W is the response writer. Yeah.
It's the same W I got here, right, in server HTTP.
And so you're just passing that in. That knows where to write it to, which is going to be to the client.
And next thing is I'm going to give a message. I'm just going to put the what for now. Right.
Sure.
You
could say something like the method, and then the method name, like we don't handle this.
Yeah.
We don't handle this method, or whatever. But yeah,
don't know what this.
And this you could interpolate it. But
I'll put what for now. Sure. And then the code, right? Takes an integer. So the code we needed was
405.
Yeah. So I'm going to type that in there. Now I will tell you that technically Go has a bunch of constants you can use rather than writing 405, but we want to keep this simple. And I think like just seeing 405 makes it more obvious what's happening. And of course this comes from the HTTP package. So I got to stick HTTP because the documentation does not put it there. Okay. So let's see what happens. Okay. So I'm going to run this, and it's begun. Fantastic. And let's go to the server, and we're going to run this again. Okay, so what I want to do is actually let's just make sure get's still working, right?
Okay.
So first I'm just going to just check that. Let's just make sure that code change didn't affect anything else. Okay, seems like it works. So this is get.
Mm-hmm.
Okay, so let's clear that. And now I'm going to do punch. Oops, punch. Oh, interesting. So it worked. So first, like the what appeared there, that's good.
Yep.
But like notice here, 405, not
Method
200,
not
right?
allowed. Yeah.
Method not allowed, right? So it worked, right? We were able to handle that error,
Yeah.
and that's cool.
That is cool.
Okay. So let's kill this now.
So actually, that was with punch, and that was because punch isn't handled, right? The method is not allowed.
Yeah.
We don't have any way to deal with it,
But
and that would happen with any method that didn't. Yes. Okay.
Yeah. Like if we added in there, all of a sudden, like we've got.
So this is actually kind of interesting. Like we're giving this a fair amount of attention, but how often have you written like when you've been working on actual software out in the wild, how often have you used custom methods for HTTP handling?
Rarely. I have before. It's been very rare.
I could see it if you were working on say some sort of APIs for like, I mean, you wouldn't even have to, right? But you could if you wanted to say like the business analytics team, I'm doing something and I just want to be fancy almost like it. I don't see a lot of use cases where you really need to.
It's the case of how do you pass the information, right? Like I think I'm trying to do something, so I might maybe have a URL: apple, banana, cherry,
Banana.
right? Yeah, and then I have this.
You spelled banana wrong.
Did I? Oh, thanks. I thought you were just trying to be funny.
No.
Connection close. Okay, so let's say I wanted to do something besides get, right?
Yeah.
Now you might say I want to punch, right? Well, how can I do punch? Well, maybe punch equals 1. Like in this. No, I won't do that. Actually, yeah, I'll do that. Like that would correspond to like tweaking the URL. Like so, I pass the information in the URL. Punch 1. Like I can pass the information there, right? Mm-hmm. So I've tweaked the URL. That's one way of doing it. Another way I could do it is instead of that, I might do a post, and then there'd be a post body. Technically, I need to put a content length. I'm just not going to do that. And I might put here punch 1. Maybe I do that.
Yeah. So that I guess that's actually interesting because that would be a pretty common thing to do, and we haven't shown that yet. But we did look at doing custom methods, which is probably a lot less common.
Yeah, I was kind of skipping it because then I'd have to count the content length and put it in there. And I was like, oh, how many bytes? 1, 2, 3.
Yeah.
That's why I kind of avoided it. But like if I want to do a post, I'd have to do some like let's say it's like punch equals 1, right? So 1, 2, 3, 4, 5, 6, 7, and I'd have to do something like I think it's content length.
Content, not connect.
Oh, thanks. Yeah, so my code wouldn't work as I did that. Content length, maybe something like that. And the thing is, like when I type that stuff like on the fly, you have to do it pretty quick, and not just that, I have to know the length before I type it. So it's just I kind of avoid it. But anyways, getting back to the punch, like I could do that, or what I could do is just like instead of all that, I could not have that, and I could just do like that. And it's just, it's just a choice. Like some people don't use patch, puts, delete, all that. They just put everything else as a post that's not a get. Some people use those other built-in ones. Some people create their own. It depends, right? I'm okay with creating my own.
I guess it's a good use case because rather than use like the URL parameters, right?
Yeah, I think the URL parameter. Sometimes there's reasons you use it because of the library you're using it. It's really the only choice you have. But I find it a bit messy. Like I want the URL to represent that thing. It's a noun, right? In the same way methods are verbs, this is a noun. And if I add a bunch of stuff after it, technically it represents something else. It's not the same thing anymore. It's a different thing, right? Yeah. And I try to keep that clean. And it's just my choice. Like no one's forcing me to do this. And that means I sometimes use custom methods. Usually I don't. It's rare that I do, but there's been some cases when I do it. But sometimes there's constraints where you don't do that. And even when I do custom methods like this, sometimes I provide alternatives. Like you can do it like this, but you could also do it as a post. I support both. And then there's even like special headers that you can use. I can't remember what it is right now, but if you do a post, there's some method you can add that says, well, I know I wrote post, but what I really meant was this.
Yeah.
Okay.
So this actually, I think so far maybe we can do a little bit of a recap of what we did. I think we did a really good sort of introduction into here's some of the main methods, here's some of the error codes, here's how you could use them, here's how you could write your own. And as long as you're using like a standard library, like the standard package HTTP in Go, then it's probably going to be pretty straightforward to do it. But as soon as you start getting into some sort of custom libraries, you might have some issues because of the way that somebody else implemented something. So in a future episode, we might take a look at authoring our own router, for example, which is something that for some reason seems very popular in Go for people to do.
It's because the one that's built into the Go isn't very good. Or at least it's not the way people like to work.
Well, I think it's quite good. It's just not necessarily production ready for web development necessarily.
What I'd say is that I think a lot of people want a library that works a certain way, and the one built in a Go doesn't work that way. So it doesn't fit what people are looking for. So it's not. I mean, I guess I was wrong. It's not to say it's not good. It's just like, if I make a product, like you can think of like a library being a product for software developers. If it doesn't do what they want, then it doesn't help them, right? They're looking for something else, and because people are looking for something else, it's not in the built-in library. They create their own, and I actually like creating my own library, so I'm perfectly happy doing it. But I think that's probably the reason so many people recreate it, because they want something and it doesn't exist in the standard library.
Yeah. Okay, so I think that might actually be interesting to look into at some point. But for now, let's just do a little bit of a recap here, because we wrote a little bit of code. It's not actually tons, but it is quite a few maybe new concepts for some.
So we wrote this all in a single file. When your code gets bigger, you'd probably divide this up to many files, but we wrote a single file. So because this is our entry point, this is where the program starts, we have package main.
It's a funny thing. Sorry, I think I said something earlier, like, oh, making it more complex, and you're like, well, it's just kind of like how we organize things. And it's kind of interesting. Like you used a struct, and it's kind. I think it's kind of the same thing where like you can now. No, it doesn't matter. I think that's absolutely fine. I think when you decide to break something off versus not, it's relatively subjective. If you have an idea going in that like this is going to reside in 15 different files, you're adding a level of complexity in some regard, but you're also like organizing maybe in another regard, and it kind of depends on like as your code grows, if it does grow, and I guess like whether you have the confidence to make those assumptions or not is going to depend on what you know about what you're building at the time that you're doing it, right?
Yeah. I mean, a lot of it is, you're making it like when you're programming, like primarily you're programming for the computer, right? Like you need to get it to work. That's the first thing. But secondary to that, you're programming for yourself, right? Like, and
potentially for others, but yeah.
I know people say that. I don't think that's true most of the time. I think often like managers say that when they kind of want to push their own styles on software developers, but primarily it's for the computer. You got to get to work. Secondary, it's for yourself. What makes this easier for me to program, right? Like, is it like, okay, let's say you have 50,000 lines in this file. Do you personally find that easy? Maybe you do. Maybe it's the way you want to do it. But like, I sometimes find
because I like my editor crashing every time I try to open it. 50,000 lines is a lot.
I also find that's a little hard to work with, right? Like it's more difficult for me to find where something is, right? If I maybe have a type, if I have its own file for it, it's like, well, what line is that? If you had one file, what line is that type on, right? It might take me a while to find it. Where if it's its own file, I just open that file and look at it, right? And I do that for myself. Right. I do it for myself because I find it easier to work with it that way. Okay. For this, we put in one file. This was a pretty small program, so it was okay. So main is like usually where things start, you were right. There's technically inits that start before it, and there's some other things like if you have a global variable declaration, like and it has some kind of function it calls or something, that'll get called first too. But we go into main and we started off and we just print, right? And why do we have, or sorry, just printed begin. And why did we print begin? Because I want to see if it starts. I want to see if it worked, right? So I just print begin. I can tell, oh, something's happening. And then after that, you can kind of think of these being separate. After that, I have the stuff for the web server, like the kind of like the entry point. And it's really, it's this line, right? Like the rest of the lines around it kind of support this, but it's really this line that's doing the stuff.
Like you could have just written everything in there. Like you could have put the HTTP address string. You could have just defined it there. You could even have written the handler there in line.
I could have. You're
would have been pretty ugly, but
yeah, I kind of thought that probably that would confuse a lot of people. I wanted to like make it a little easier to read. So this says, I'm going to listen server. What does it mean? I'm going to start the web server, the HTTP server, and I'm going to start on the port that's in here. You see it here. I think with this, if you say your computer had a way of representing, say, multiple IP addresses or something like that, you can be specific about which one this one's attaching to, I think. So I think you put a bit more here, but for now we're just saying like, just listen to port 8080. We're not going to specify an IP address or domain name or anything. And then, okay, well, what happens when we're listening there? Well, okay, anytime someone comes, I'm listening on port 8080. Whenever anyone comes there, I'm going to serve, right? But I'm going to use this handler, right? And that's what we define below. And of course, like we check for an error, and if there's an error, we do all this. And usually what happens is that this never actually runs. Like, you notice I had to like kill the program, to press Control C to like hard kill the program right in the middle of it's running. You generally like probably shouldn't see this running. And that's why some people like take this and just panic, because it's like, it should never happen. And if it does, like you probably should panic.
The error, yeah. Well, I mean, thinking through that, a situation where it might happen would be, I don't know if you'd get an error from that, but yeah, I guess you might if the port was already in use.
Yeah, actually, that's a good point. If the port was already in use, then this should crash. Actually, you want to try that out? We're going to try it out later.
Yeah.
We'll try it out later. Okay, so now here's our type. And what is this, right? Well, I have handler, and what's handler? Handler is defined up here. And it's just something I made up. I call it my handler. And why? Because I needed something with a serve HTTP method.
Declared up there, but defined down below.
Right. Yeah. So here's my type, and it has serve HTTP method, and it's just like it's
really the only real reason in this case that you have a handler is as a struct is to namespace your method, kind of like
it's partly because this is an interface, and to make it match the interface, it needs to be something that has methods, because the interface represents like a bunch of methods. There's some workarounds where I didn't have to define the type. Maybe I'll change the code so we can do that. But
you could have just written like a handler func.
Yeah, but then I would have had to like typecast it. I can switch that to this later. But okay, so we have this serve HTTP, and I print this to the console when it hits it, because I just want to see that the server get it, like something happened there. Because if it doesn't, I want to know like, well, what's going on, right? And I use these prints to kind of like tell me what's going on. And then you can see here, because we were interested in the method, we went and we output the method also on the console for the server. And then we went and handled these different methods, and we just like decided which methods we're going to handle. We decided get, post, scream. I wrote a punch, but we never tried, so I'll just delete that. And then if we didn't know what it was, we return this error, the 405, right? Yeah. And that's pretty sophisticated. And
that was kind of a catch-all to say, hey, we're not going to handle this method. There's an error. What?
And we picked 405 because it seemed to be the closest thing to what we intended in the HTTP spec. Yeah, we could have picked something else if we wanted, but we just
or defined our own custom one. So an interesting thing to note here is that in all of these, all of the other cases, we've written to using format f print line.
Yeah.
and we've written back to the request. But in the default case, we've called the HTTP error method,
Yep.
which probably does something. Actually, if we look at it, I don't know if we can, but if we look at it, it probably does pretty much exactly the same thing already anyway.
So
there it is. Yeah, and okay, so here's a couple of things that we didn't actually look at, but if you look at the last line there, the FMTF print line W error does exactly what we've done. The difference here is that here we also have like W header dot set. So we didn't go over this kind of stuff, but we could also have been customizing or writing our own custom headers.
Yeah, so we didn't get into creating our own headers, but like this is the type of thing that you can do to write a header.
Yeah.
And then you see like it kind of like set these up, and then it went and wrote the headers, and then it wrote the body.
Right.
So we're just kind of like writing the body, and it's just because we're writing using this, the response writer is sophisticated enough to say, oh, you didn't put any headers? Okay, I'm just gonna like guess it's some headers for you, dump those, and then just write the body for you. Okay, so
probably very similarly to how the HTTP.error does.
Yeah. So let's. I'm just gonna do that one thing just to check. Like we were talking about, like here, when might we get an error? So let's
yeah. If the port's already in use.
Yep. So let's kind of just see that. So I'm gonna run this. Okay, this one runs fine. So I'm gonna open another console.
The opposite way may be a little easier, but
okay. So here it's running.
Yep.
I'm gonna run it. I'm gonna run it again. Go run main.
Oh, I see. Yeah. Good idea.
Error.
Yep.
Error. Something bad happened with the web server.
Perfect.
Listen TCP 8080 bind address already in use.
And okay, so the error message was the address already in use, and the something bad happened with the web server was what you wrote in the handler, the error handler.
Error. Something bad happens with this web server. You can see that error. Something bad happened with the web server. That's what I have here.
Yeah.
And then you see %s in the error. So then that's just whatever the error contains, right? And the error contains
the string, the error string.
Yeah, from here to here. Yeah. So and like I'm familiar with Go, so it looks like there's like a couple errors. So listen, it might have been like 2 levels of errors, like this.
Right,
error,
like it couldn't bind because the TCP address is already in use.
Yeah, well, this error probably contained another error inside of it. So it also did something like this where it printed and then it gave you the message of the nested error, which is a common pattern in Go. Okay, so we did that, and let's do one more thing because I think we probably got a bit more time. You kept on saying like we don't have to create the type. Absolutely right. So probably the way I would do this normally is I wouldn't have the type, and I would probably just create something like this. I might not call it serve HTTP, but like I'll just kind of keep it simple. And then what we do here is we get rid of this.
And then you don't need handler, and you can just say serve HTTP.
I'm going to do it like this, var handler, and then HTTP handler, just to keep it. And then there's a method. Here we go, handler func. So what I need is HTTP handler func, and then so I called it serve HTTP, and then I would typecast it, right? And you can do this in line here. I just kind of like kept it separate. And then if you run this, it should work. Yeah, it works. Excellent. So that's the way I'd probably more likely do it. I wouldn't bother with a type. I just create, like it's not a method in this case, it's a func because it's not attached to a type.
Yeah.
And I would just do something like this. I might just like put this code straight in here instead of declaring a variable.
Yeah, I suppose, I guess, it might actually be easier to read the other way around.
Yeah.
I don't know.
I might do this. Like if I was writing this code and then not bother with this.
Yeah.
And I could even put like this, although sometimes I'd keep that separate just because
Yeah,
It
or you
helps
could
with
read
error
it from like
messages.
an environment variable or
Yeah,
whatever. Pass
I
it.
put it somewhere else, like it's a constant, like rather than this
Yeah,
file.
yeah.
But like that's the idea. So it runs.
Hmm.
Yeah, cool. Um,
Very cool.
Anything else you think we should cover for today?
Honestly, I think that's really good. We did all of the stuff that we wanted to do. We also set ourselves up to discuss things like how to actually handle HTTPS if we want to discuss that at some point. Maybe why,
Yep.
what that is, and so maybe we can talk a little bit about that in certificates in the next episode, maybe,
Yep.
and talk a little bit about how we might set that up, and then maybe not yet, not code it out yet, but maybe.
Yeah.
And then we could also even discuss some other things like
You talk about creating a router.
creating a router. Yeah.
I think also the what some people call middleware
Hmm.
in Go is really like when you start doing like APIs or like anything over HTTP and Go, you're
Hmm.
probably going to create your own middleware at some point, and like
Yeah.
that's a pretty cool thing to learn.
Well, I mean, that's sort of what I was thinking when I said router as well.
Yeah, yeah,
Sometimes, I think when people say middleware, it's not always obvious to me, at least, what people mean when they say words. Sometimes, like that might sound like a really
yeah,
idiotic thing to say, but it's true. I mean, like if I look at uh, what was once called, I don't know if we still call it like a data-driven web application, which is basically like almost any application that has a database and a user interface, which is a lot of applications. Um, you can almost think of like you have a client side or like a web UI basically where people are interacting with the application. Then you have your code, and then you have a data store or a database API or the database, however you want to call it. And I almost think of like the entire application as, I guess, yeah, as a middleware.
yeah,
But maybe that's like your business logic or whatever. And so, what people often mean, I think, when they say middleware, would be like you grab like somebody else has already solved the problem. So, for example, you might use like somebody else's authentication middleware.
yeah. I mean, sometimes you are using someone else's middleware,
Yeah.
but like in a lot of cases in Go, like you're creating the middleware and then reusing yourself or maybe sharing it with others.
Hmm.
It's just kind of a pattern that people use a lot.
Yeah.
Um, yeah, so I mean that would be an interesting thing to get into also.
Yeah, I think that'd be a lot of fun, and even some other things uh, like looking at um, some of the common middlewares or some of the common routers. For example, I think like there's Gin, um, there. There's a couple others. I can't think of the names at the moment, but like we can take a look at maybe kind of peruse the docs and look at setting something up quickly with them, and then maybe dive a little bit deeper into like what are some of the trade-offs and what are the things you're going to hit once you do this, once
Yeah,
you start using this.
yeah,
And even I think we could actually look at it from sort of both ends. So if we're talking about like the router or like the API, the web API, then we're really talking about the communication between the application and the browser. But if we look at the other end, when we start to look at the database and your application, well, then we can start to look at writing our own functions and raw SQL, versus
yeah,
baked SQL or cooked SQL. I don't know, but we can write our own functions and write our own API basically into the data, or we could use like an ORM, like GORM or Go
yeah,
ORM, uh,
yeah,
and then we could talk a little bit about some of the trade-offs there. And I noticed that like um, one of the things that an ORM I think aims to do is provide a common interface for whatever sort of database you may be using, and that often means that there's trade-offs, and some of those trade-offs are now you're not leveraging the power of a particular type of database. For example, like Postgres versus MySQL, you might not be able to access some of the benefits of using one versus the other if you're using an ORM.
yeah,
Maybe we can look at that. I think that'd be pretty fun.
yeah.
What do you think?
Sounds good.
Awesome. All right. So for this, we'll get this up on our YouTube site as well, and we'll add a code repo and some Markdown to go along with that as a bit of a tutorial.
Cool. Sounds good.
Awesome.
Okay.
Good
See you
chat.
next time, Drew.
See you next time.